All right, let's jump straight into this explainer. Today, we're completely transforming how we think about getting back on the track or the field after an injury. For way too long, return to running protocols have literally just relied on guesswork. Feeling it out and crossing our fingers. Well, we're ditching the guesswork entirely today. Instead, we're going to unpack an objective, data-driven return to running protocol guide. It's essentially a concrete roadmap for athletes and clinicians alike.
And it all really starts with this quote from Dr. Rich Willey. He says, "Running overuse injuries are always a training load error, and biomechanics just dictates where it'll show up." Honestly, this is the fundamental truth, and it's kind of the villain of our story today, the injury load mismatch. You see, injuries aren't just a stroke of bad luck or, terrible genetics. They're a mechanical error in training load. You put too much stress on a tissue that simply wasn't prepared to handle it. Your biomechanics, like how your foot strikes or how your hip drops, that just determines exactly which tissue is going to scream first.
So to fix this, here's our agenda for today's explainer. We'll cover the injury load mismatch, 2 types of athletes, mastering your starting speed, rebuilding the running machine, mastering change of direction, and finally, the final speed frontier.
All right, Section 1, the injury load mismatch.
Think of this as the battleground between what you're doing to your body and what your body can actually handle. It's applied physical load versus tissue load tolerance. So imagine you've got a washing machine, right? And it has an 8-kilogram capacity. You're tired, you're in a rush, so you just keep shoving one more heavy wet towel into the machine. Eventually, what happens? The machine throws an error code, it just stops to prevent itself from completely exploding. That is exactly what happens to your tissues. Running overuse injuries manifest when the training demand placed on your tissues just totally exceeds the tissue's capacity to handle that demand. You overloaded the machine, and the resulting injury, that's just your body's error code.
So how do we clear that washing machine error? Well, we have 3 distinct strings we can pull for capacity restoration. First, we can literally get a bigger washing machine, meaning we increase tissue capacity through targeted strength and plyometric training. Second, we can do smaller loads. We decrease acute loading through technique modification, like adjusting your running cadence. And third, we use graded exposure and reintroduction, setting really specific, acceptable pain targets and systematically building back up.
Which brings us to Section 2, 2 types of athletes. Right here, we hit a massive fork on the road. Why? Because a single one-size-fits-all rehab approach absolutely does not work. On one side, we have our endurance athletes, think marathoners and distance runners. Their injuries are usually chronic overuse from just a massive volume of running, and the onset is super gradual. But on the flip side, we've got our field and court athletes, soccer, football, basketball players. For them, injuries are often acute. They happen in a split second. Their sports are intensity-focused, requiring maximal velocity, sprinting, and agility. So obviously, their distinct training histories and ultimate performance goals dictate completely different rehabilitation focuses. I mean, you absolutely cannot treat a marathoner's shin splints exactly the same way you treat a soccer player's blown hamstring. Make sense?
Okay, moving right along to Section 3, mastering your starting speed. Probably the most crucial question any injured athlete asks is, okay, how fast can I actually run on my very first day back? Well, the answer starts with this number, 70% LSI, or Limb Symmetry Index. Listen, this is the absolute golden rule. Before you even think about initiating a return to running protocol, you need greater than 70% limb symmetry on your functional tests. Basically, your injured leg needs to be performing at least 70% as well as your healthy leg in things like strength, hop testing, and movement quality. If you don't have this baseline, you have absolutely no business running it.
But once you do hit that 70% mark, how do you actually pick your speed? We can break this down into 3 evidence-based approaches. First up is self-selected, which is great for recreational runners who really just want to run at a comfortable pace. Second is symptom-limited. This is highly effective for pain-dominant or reactive injuries. You dictate the pace strictly by pain thresholds, like, for example, making sure you're staying under a 2 out of 10 on the pain scale. And the third, and honestly the most precise method, is MAS-based, which stands for Maximal Aerobic Speed. This calculates your baseline speed using a time trial, and let me tell you, it is absolute gold for competitive and field sport athletes.
And here is the golden formula for using that MAS data. You just align your MAS percentage with your LSI percentage. So let's put that into perspective. If your functional tests show you have an 85% limb symmetry index, then on your very first day back, you start running at exactly 85% of your maximal aerobic speed. It's just an incredible clinical pearl. It completely transforms rehabilitation from this vague, cross-your-fingers guesswork into a precise, objective mathematical formula that scales perfectly with your current functional capacity.
All right, let's dive into Section 4, rebuilding the running machine.
Because here's the thing, before you even think about layering on massive speed, your technical foundation has to be flawless. We use the ABCDE teaching framework to rebuild that foundation. A stands for trunk position, keeping a nice neutral spine and looking out at the horizon. B is trunk and hip control, really maintaining that lateral hip position so you don't drop side to side. C is arm drive. Actually, my absolute favorite cue here is avoiding chopstick arms. Your arms should drive forward and back, not crossing the midline of your body like a pair of chopsticks. D is leg mechanics, dialing in that proper hip and leg cycling. And finally, E is choosing your speed, which of course we just mastered using our golden formula.
Now, to actually reinforce that A to D mechanics framework, we use a very specific progressive drills library. You start super simple with A marches and skips just for basic hip flexion. Then you build up to B marches, fast feet for ankle stiffness, butt kicks, and those more complex F drills. Eventually, you'll progress all the way up to wickets and heavy bounding for your plyometric capacity. And guys, these aren't just warm-ups, okay? They are systematic tools designed to restore your tissue's mechanical capacity.
Let's move on to Section 5, Mastering Change of Direction.
Because out on the pitch, running in straight lines is really only half the battle. But we need to make a really critical distinction here. Change of direction, or COD, is a pre-planned movement. You run to a cone, you know exactly where it is, and you turn. It tests your purely physical and mechanical capacity to brake, plant, and accelerate. Now, having great COD mechanics drastically decreases your injury risk, but here is the catch. It has absolutely zero cognitive requirements.
And that is exactly where agility comes in. Agility is a reactive movement to an unknown stimulus. It tests your decision-making. It combines those cognitive and perceptual skills with actual sport-specific context. So why does this matter so much? Because an athlete who has amazing mechanical COD but really slow cognitive reactions is still incredibly vulnerable to injury on the field. If you can't react to a defender stepping on your toes in real time, all your perfect cone drill mechanics aren't going to save your ACL.
Let's see how this actually builds using the Kelly-Penfold Agility Continuum. This is just a brilliant, systematic progression. You start with Phase 1 COD, simple, planned cone drills. Then, you do the exact same drills but add a visual or auditory cue, transforming it into Phase 1 Agility. Next up, you increase the speed and complexity for Phase 2 COD, and finally, you reach the top tier, Phase 2 Agility, where you're removing the cones entirely and reacting to actual human opponents. You absolutely cannot skip steps here. You've got to build that mechanical foundation before layering on reactive, sport-specific complexity.
All right, final stretch here. Section 6, the final speed frontier.
Before any athlete gets fully cleared for contact or competition in these final stages, they have to hit these objective, gender-specific speed benchmarks. We're looking at high-speed running thresholds of over 5.5 meters per second for males and 4.5 for females. We're demanding true sprint speeds of 7.0 and 6.5 meters per second alongside some really hard acceleration metrics. Listen, these aren't just polite suggestions. These are the absolute non-negotiable physical demands of the sport.
And those benchmarks tie directly into a really fascinating concept, anaerobic speed reserve, or ASR. Basically, ASR is the mathematical difference between your absolute top speed and your maximal aerobic speed. If your top speed drops, maybe because you haven't rehabbed quite right, your ASR shrinks, and a smaller reserve means that during standard gameplay, you're working at a dangerously high percentage of your maximum effort. The result? You're going to fatigue faster, your performance will totally tank late in the game, and your injury risk skyrockets.
Which brings us to the ultimate takeaway of this whole explainer. You must restore both your aerobic capacity, your MAS, and your top speed back to their pre-injury levels. Returning an athlete to the field with great endurance but a depressed top speed, you're basically creating a ticking time bomb for re-injury due to that rapid fatigue accumulation we just talked about. You have to rehabilitate both ends of the spectrum, no exceptions.
So as we wrap up, I want to leave you with this provocative question to really think about. Are you just running fast, or are you actually ready for the game? Next time you or someone you know is coming back from an injury, take a hard look at the protocol. Are you relying on guesswork and hope, or are you using the objective, data-driven metrics, symmetry indexes, and speed reserves we've unpacked today? Demand the data, pull the right strings, and rebuild the machine the right way. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you on the next one.